Welcome back. We have a question here that involves equilibrium and organic chemistry. And the question reads, 1 mole of ethanoic acid is mixed with 1 mole of ethanol in a closed vessel at 298 Kelvin, which is the same as 25 degrees Celsius. Reaction occurs to give an equilibrium mixture, part of which is 0.66 mole each of ethyl ethanoate and water. Question A. Write a balanced equation for the above reaction. Question B. Write an equilibrium constant expression for the chemical reaction at 298 Kelvin. Question C. Use the expression to calculate the equilibrium constant Kc for the reaction at 298 Kelvin. And question D. State whether the constant carried units or not. Okay, now what we have to understand here is in this reaction we have ethanoic acid that is reacting with ethanol to produce ethyl ethanoate and water. Okay, so this type of reaction is called esterification in chemistry. Okay, esterification is the process by which a carboxylic acid or an alkanoic acid reacts with an alcohol to produce an ester. This ethyl ethanoate is an ester, is a sweet smelling compound. Okay, now what we can say about ethanoic acid is that it belongs to a group of organic compounds called carboxylic acid. Okay, carboxylic acids are also called alkanoic acid. Alkanoic acid. All right, and ethanol belongs to a group of organic compounds called alcohol. Alcohol. Okay, ethyl ethanoate belongs to a group of organic compounds called alkanoate. Alkanoate. Okay, which are also called esters. Okay, so to repeat myself, when alkanoic acid and alcohol reacts, we produce an alkanoate, or otherwise known as ester. This process is what we call esterification in organic chemistry. All right, so how do we identify compounds to be carboxylic acid or alkanoic acid? Well, they carry a functional group called the COOH. Okay, how do you identify a compound to be alcohol? It carries a functional group called OH. How do we identify a compound to be an alkanoate or an ester? It will carry the functional group of COO. Okay, for water you already know that it is H2O. So before moving on to answer the question, there are certain things I want to make clear. That is why I'm taking my time to explain this. Never confuse the alkanoic acids with alkanoate. This one is just OATE. This one is noic acid. You take an alkanoic acid, mix it with alcohol, you will produce an alkanoate or an ester. Okay, so there is a lot of compounds that you have to deal with in organic chemistry. The simplest form of the organic compounds are called the alkanes. Okay, Now, for an alkane, let me just give you one example. If I have this compound that is just having a single carbon, it is what we call methane. So the chemical formula will be CH4. That is, it contains one carbon with 4 hydrogens. Okay? So another example of alkanes is the one that will have 2 carbons, right? So we have 2 carbons, and this is called ethane. Okay, always will have ANE because you have only one single bond. Okay, there is only one single bond. These are called the alkanes. For 3 carbon atoms, we will call this propane. Okay, so I don't know whether you can identify a pattern here. Organic compounds that have only single bond are called alkanes. Okay, and if it is only one carbon is methane, 2 carbons is ethane, 3 carbon is propane, 4 carbon is butane, 5 carbon is pentane, and so on. Now, whenever met comes, it is 1. Et is 2, prop is 3, but is 4, pent is 5. That is what I want you to understand about this. Well, if this alkane that we talked about lose one of their hydrogen, we have a different functional group. Okay? And those are called the alkyl groups. So which means the simplest form of alkyl will be CH3, which we call methyl. All right? Then the second will be C2H5, which we call ethyl. Right? If you look at this, if at all the ethane loses a hydrogen, then we'll have 2 carbons and 5 hydrogens. Okay? So what will be the name of an alkyl group with 3 carbons? It will be CH7, right? It will be propyl. With 4 carbons, it will be butyl, right? With 5 carbons, it will be pentyl, right? So alkyl groups are formed when an alkane loses a hydrogen. So the general formula for the alkyl group is CnH2n plus 1, where n is the number of carbons. For example, if I want to establish the formula for methyl, which is 1 carbon, it will be C1H2 into 1 plus 1. So that will be C1H. 2 times 1 is 2, plus 1 will be 3. So that will be CH3. That is how the methyl group becomes CH3. So if I want to establish the chemical formula for ethyl, where we have CnH2n plus 1. So ethyl is 2 carbon. That will be C2H2 into 2 plus 1. So that will be C2H. 2 times 2 is 4 plus 1 is 5. So whenever we say met, we are talking about something that carries 1 carbon. Et, something that carries 2 carbons. Prop, something that carries 3 carbons. But, something that carries 4 carbons. And pent, something that carries 5 carbons. All right? Now, I believe this is a good introduction to organic chemistry. So we will now move on to see what we can do with the question that we have. All right. So we have an ethanoic acid. An ethanoic acid simply means that that organic compound will have two carbons, right? So that will be C, and the functional group is OOH. And remember, there is a double bond, okay, connecting one of the oxygen to the carbon. All right. Okay, we've said that the ethanoic acid belongs to a group of organic compounds called the alkanoic acid or carboxylic acid, and they are identified with this formula COOH. Then what I can do with this carbon, let me just fill it with hydrogen. So we'll have H. Okay, this is the structure of ethanoic acid. Okay, it is like this. Ethanoic, given the sense that it has two carbons. And how do we say ethanoic acid? Because it carries this functional group COOH. All right, so what will be the chemical formula if I want to write it? That will be CH3 COOH. Okay, C, and around it you have three hydrogens, 1, 2, 3. That's why it is CH3. Then you have the other C, and then you have 2O with a hydrogen. So if I want to compress this further, I can say C2H4OO, right? So why? Because you have two carbons, C2. How many hydrogens? 1, 2, 3, 4. 4 hydrogens, and then 2 oxygen, OO. So this is the chemical structure of the ethanoic acid. So, but what of ethanol? We said that ethanol belongs to a group of organic compounds called alcohol, and the functional group of the organic compounds for alcohol is OH. So because it is eth, it means it has two carbons, right? So that will be CC, and remember one of the carbons is going to have the OH group. Then I can fill the rest with hydrogen. So that is why we have the chemical structure of ethanol as this. So if we want to write the chemical formula, that will be CH3 CH2OH. Okay, C surrounded by 3 hydrogen, then we have another C surrounded by 2 hydrogens, then attached we have the functional group OH. So if at all I want to compress this, I can write it as C2H5OH. Okay, that is the total carbon is 2, total hydrogen is 1, 2, 3, 4, 5, and then we have the OH. So this is also another way of writing the chemical formula for alcohol. Either you write it as CH3CH2OH or C2H5OH. All of them is correct. All right. Now, moving on to ethyl ethanoate. We said that ethyl ethanoate belongs to a group of organic compounds called the alkanoate or the ester. Okay? And they have the functional group of COO. But there is an interesting way of drawing the structure of the alkanoate or the esters. Because if you look at the name ethyl ethanoate, you have two structures, ethyl and ethanoate. So you have an ethyl group and then you have an ethanoic. So the ethyl group comes from ethanol, the ethanoate comes from the ethanoic acid. So how do we draw the structure of ethyl ethanoate? Let's try to draw the functional group first, which is C. Remember, it will have a double bond, O, and another O. Okay? Then on this oxygen, let's try to bind the ethyl group. So the ethyl group will have two carbons, right? 1, 2, and it will be surrounded by hydrogens. 1, 2, 3, 4, 5. So this portion is called the ethyl. Okay, it is the ethyl. And from this portion, we will try to write the structure of the ethanoate. All right, and ethanoate, again, eth simply means it has two carbons. So one of them is already this one, so which means we have to add one carbon again. All right, then we surround it with hydrogen. So that is the ethanoate. So which means this is ethyl ethanoate. So this is the structural formula of ethyl ethanoate. You have the ethyl group C2H5, right? Because you have two carbon and 5 hydrogen, and this is the part that comes from the ethanoic acid. So let's try to write the chemical formula for ethyl ethanoate. It is CH3 COO, okay, CH2 CH3. We can also write it as CH3 COO C2H5 by adding this side together. We have 1, 2 carbons and how many hydrogens? 2 plus 3 is 5. So that is ethyl ethanoate for you. All right. So going to the question now, I think the introduction to the organic chemistry is enough. It asks us write a balanced chemical equation for the above reaction. So that is question A. Question A, what do we have? We have an ethanoic acid that reacts with ethanol to produce ethyl ethanoate and water, right? So what is the formula for ethanoic acid? It is CH3COOH, right? What is the formula for ethanol? Is C2H5OH, if we like. This will give ethyl ethanoate, which is going to be CH3COO C2H5, then plus water. Now let's see if the chemical equation is balanced. The number of hydrogens, oxygen, and carbons that we have on this side must be equal to the number of carbons, hydrogen, and oxygen that we have on this other side of the equation. The number of moles must be equal on both sides of the equation as well, if at all the equation is balanced. So how many carbons do we have here? 1, 2, plus these 2, making it 4. Do we have 4 carbons here? This is 1, 2, 3, 4. Carbon is balanced. How many hydrogens? We have 3 here, plus 1, 4, plus 5 is 9, plus 1, making it 10. So how many hydrogens do we have here? 3 plus 5 is 8, plus 2 is 10. Okay, so how many oxygen? 1, 2, 3. 1, 2, 3. Oxygen is balanced. So the chemical equation is balanced, and that answers question A. All right. So question B is asking us to write an equilibrium constant for the chemical reaction at 298 Kelvin. All right. So question B, how do we write an equilibrium constant? Well, to write the Kc, you have to multiply the concentration of the products that is divided by the concentration of the reactants. Okay, so Kc is equal to CH3 COO C2H5, water is H2O, then this is divided by CH3 COOH C2H5OH. Okay, this is the expression for Kc. This equation has reached an equilibrium, then it means the rate of forward reaction is also going to be equal to the rate of backward reaction. So that is why I will emphasize that not to forget to indicate that the reaction is both going forward and backward. All right, so this answers B, to write an expression for the equilibrium constant Kc. All right, now because the mole in front is just one mole, one mole, one mole, one mole, I don't need to indicate it here. But assuming that you have 2 moles or 3 moles or 4 moles, then like you are supposed to indicate that on top of this. All right. So what did it say? The question, it says 1 mole of CH3COOH reacted with 1 mole of ethanol, but how many moles of ethyl ethanoate and water were produced? Each was 0.66 mole. 0.66 mole. So 0.66 mole of ethyl ethanoate was produced and 0.66 mole of water. So what does this mean? It means that not the entire mole of ethanoic acid or ethanol was completely used in the reaction. So if 1 mole of ethyl ethanoate and 1 mole of ethanol was supplied, but only 0.66 mole of ethyl ethanoate and 0.66 mole of water was produced, this means that not all the ethanoic acid or ethanol was involved in the reaction. So how do I know how many moles of ethanoic acid or ethanol was involved in the reaction? Then I have to subtract, right? 1 minus 0.66, it means that 0.34 moles of ethanoic acid was involved in the reaction. The same thing, it means 0.34 moles of ethanol was involved in the reaction to produce 0.66 moles of ethyl ethanoate and 0.66 moles of water. So we are going to use that to calculate the equilibrium constant. Okay, so that is what question C is asking us. So we say that Kc is equal to the concentration of CH3 COO C2H5, concentration of water, divided by concentration of the ethanoic acid CH3COOH and C2H5OH, which is the ethanol. So we are not given concentrations, but if mole is what is given, we can use the mole. Okay, so what was the mole of the ethyl ethanoate? That's 0.66 multiplied by the mole of water is 0.66 divided by the mole of the ethanoic acid is 0.34. This is the one that has been used, and the mole of ethanol that has been used was 0.34. Then if you do the math, you will end up having 3.768. Okay, now does it have any unit? No, because it is a ratio of concentrations, okay? And in fact, that is the question that is asked in D. The equilibrium constant has no unit because it is a ratio of concentrations of the products and the reactants. Therefore, the units cancel out. Okay? So let's say the concentration of the products is in moles per dm cube, and the concentration of the reactants is also in moles per dm cube. So what happened? They will cancel out. So that is why it has no unit. All right? And that is all for this video. Thank you very much. If this is the first time of visiting this channel, please like the video, you can share it, and please subscribe to the channel.